Welcome to Bits of Java. Let's talk about searching. So sequential search and binary search are two common searches you run across. The sequential search is just as it sounds. You're just looking through a particular list, one item at a time, to see if we find a match. Which, it works if you've got a small list, but if you've got, let's say, 1,000,000 items in it, best case scenario, you're going to find it on the first try, and it'll be right in the front. But worst case scenario, it could be near the end of the list, so it might be 1,000,000 times before you actually find the item. So sequential search is just about looking through the list in order, one at a time. And yeah, you've got a great minimum case scenario, but your worst case scenario is pretty terrible. So that's where binary search comes in. Binary search, like if you were playing a guessing game and I was thinking of a number between 1 and 100. So I got 1 and I got 100 over here. What would be a logical first guess if I told you that, I'll let you know if you're going higher or lower, if you're too high or too low. So you're right, yes, 50 would be the optimal guess. And if I say, no, 50 was too high, well then that means I shouldn't bother guessing any number above 50, so I can take this entire list from 50 all the way over to 100 and just cross it out. Why even bother looking at any of those numbers? In fact, my new maximum value I should look at would really be 49. And again, if you were to think of like what a reasonable guess would be, you're right, it'll be 25 for the next one. Well, that's because 1 plus 49 is 50, so the average of those two, the average of the low and the high, is 25. So yeah, smack dab in the middle. Well, if I say, oh no, that's too high. Well, if 25 is too high, then I can take everything that's to the left of the 25 and I can cross that out. Which means that my new low is 26, and now I've got the area between 26 and 49. And we'll keep cutting it in half over and over and over again until you approach an answer. So how much more efficient is this? Well, with 100, you actually only need 7 guesses to actually get it. That's the worst case scenario, 7 guesses. If we had a list of 1,000, then that would be 10 guesses. Now, why is it 10? Why is it 7? Well, we're looking at, since we're cutting it in half, we're looking at powers of 2. So we're saying 2 to some number x, that's going to equal the size of the list. So this is a logarithm we can use to solve it. So log base 2 of x gives you, log base 2 of the list size gives you your x value. Which means that 2 to the 10th, well, that's 1024. So that will take you to 1,000 values. If it's actually 1,000, it'll be like 2 to the 9 point something, but 10 guesses is the minimum. And if you keep doing this, actually, for 1,000,000, 20 guesses is all you need. For 1,000,000,000, 30 guesses is all you need. So the binary search is just way more efficient than the sequential search. So what does it look like in code? Here's the code right here. So this one's done recursively. First thing we do is we find the midpoint, average low and high together. Now if we keep guessing and our low ever crosses the high, that means that we couldn't find the number at all. It doesn't exist. We'll return a -1. And we'll see how low could become higher than high in a moment. If we find a match, if it's here, then great. We can send back the location that has the number we want. If it's too high, then we should cross out everything above the midpoint, and our new high is mid -1. And then we'll just binary search again, just like we saw in the previous example. And then lastly, if it's too low, then we'll chuck out everything that's below the mid, and our new low is the midpoint +1, and again, we'll binary search one more time. So it's this high equals mid -1 and this low equals mid +1 that could eventually cause low to become larger than high, and that's the case when we don't find it and it returns -1. So for a binary search problem, an example from a previously released test involves something along the lines of how many times would you have to search through a list of a certain size. So if I said I had a list of 500 numbers, how many times would I have to search? Well, just look at your powers of 2 and just see how many will take you above 500. And since I know that 2 to the 5th happens to be 32, 2 to the 6th will get me to 64, 7 is 128, 8 is 256, 9 is 512. So 9 guesses is what we would need to find a number with binary search out of 500 items. Now this brings us to the last point. What happens if our list is out of order? If it's out of order, we cannot automatically assume that we can get rid of all the numbers that are to the left of a certain position or to the right of a certain position. So binary search, the prerequisite for this is the list must be sorted before searching. So that is the one caveat to using binary search. It has to be sorted before you can do a binary search.